The nth term formula. Rather than saying term 3 is 19, there is a shorthand notation for this. T3 is 19. So let's suppose we had a sequence that went the same as we used in the previous explanation. 10, 13, 16, 19. For this one, we would say T1 is 1. Remember, the term 1 is also often called A. T2 is 13. T3 is 16. T4 is 19. On this basis, the 100th term would be called T100. The little number beside the letter T tells us which term it is, and we've discussed that over here. Tn, it's worth looking at Tn. Tn is referring to the nth term, and that means it's a general term, and n can be any number we choose later on. So it's a general term in the sequence, and there is a rule to find the nth term, and we'll look at that in a moment. But just bear in mind that the term after that would be Tn plus 1, and the term before would be Tn minus 1, because n plus 1 is 1 more than n, and n minus 1 is 1 less than n. So let's look at the rule for the nth term for this type of sequence. It is that Tn is equal to a plus n minus 1 d. Now let's just explain that. If we think about an arithmetic sequence, the first term we call a. To get the next one, we add the constant difference. To get the next one, we add another constant difference. And then to get the last one, that I'm going to write down anyway, the fourth one, there'll be lots more. Note here that this is term 1, and it has 0 d's. This is term 2, and it has 1 d. Term 3 has 2 d's. Term 4 has 3 d's. So there's always one less d than the term number, and that's where the n minus 1 in this formula comes from. In this formula, a of course is the first term, d is the common difference, and n is the particular term we want. So if we want the 100th term, we put in n equals 100, and we need to substitute that both here to get T100, and in here to get 100 take away 1 in the bracket, or just write 99.